Hi, Viper chemistry students. Let's take a look at the solving of problems involving nuclear decay formulas. Okay, so nuclei, radioisotopes, can uh, emit radiation, alpha, beta, and gamma. There's a couple types of beta, but alpha and beta radiation involve subatomic particles that are released from nuclei, whereas gamma is just energy release. So let's take a look at how we would solve our problems involving these ideas. So um, alpha decay literally means that the radioisotope nucleus is going to emit a helium nuclei. So the way this is shown in a formula set up here is that you use an arrow because the particle is going to be emitted from the nuclei. And this is a uranium-238 radioisotope. So if we emit a helium nuclei, that means that there's 2 protons and 2 neutrons going to leave the nucleus of the uranium. So what ends up happening then is we end up with a different element. So 92 reduces the atomic number of 2, reduces by 2, so we'd have 90. And then the atomic mass number reduces by 4 because of the 2 protons and the 2 neutrons. So that results in 234. So now we have a new element, and it turns out that's thorium. So what you have to do when you do these problems, you have to look up on the periodic table, what is the new element that's formed? So that's how that's done. Now, in beta minus decay, this is a little different. What this involves is the symbol that is used looks like this. E for, I guess, electron in a sense. It's thought of as thinking of the nuclei, one of the neutrons breaking apart into an electron and a proton. And so when the electron gets emitted from the nuclei, that basically creates another proton. So now this number, 55, becomes 56, atomic number 56, and again, a different element is formed. Now the atomic mass doesn't change. Remains 137 because 0 represents really no minimal mass. Okay, so electrons have minimal mass. Now that creates the element of barium. So 56, when you look at it on the periodic table, is barium 137. Okay, now beta plus decay is a little different because there is something called a positron, which has the same mass as an electron, but it results in as if they were losing a proton. So we'll start with sodium 22, and the symbol that is used here is very similar to the symbol we see here in minus decay, but instead of a minus, there's a plus. This is representing a positron, which really results in as if a proton is leaving the nucleus of the sodium. So what we end up, of course, getting here would be 10. Okay, we're losing 1 proton, and so now the atomic number becomes 10, which turns out is neon. And again, the atomic mass doesn't change. Okay, so there's some problem solving there that I'm asking you guys to do. And that's kind of how you work these out. And there's some practice problems there for you. So, like always, if you have questions, don't hesitate to email me. And also, we'll probably be talking about this in the Google Meet. So, all right, thanks for watching, and good luck.